For 1002 question 3 with the elimination method, it's a little bit more difficult and a little bit more thought needs to go into it. For the first two questions, they were telling you to either add or subtract. What we notice in the adding questions here is that one of the variables was positive and one was negative, which meant by adding them we would eliminate the D or the W or the 5H. For question 2, what we notice is that the variables are the same. There's not one positive and one negative, and we could subtract to remove them. But you might look at question D and say one's positive, one's negative, but the terms that are the same, which is the 3x, they are both positive, so we can subtract to eliminate those. Going to question 3, we first need to decide whether we're going to add or subtract, and we also look at the questions and say no two variables are the same. We have 3w and 2w, q and 3q, or 2x, 3x, m and 2m, so nothing's really the same. What we can do though is we can multiply any equation to keep the same answer. If we look into that a little bit, let's just take a simple if we go 1 plus 2 equals 3. If I were to multiply every single number there by 5, I'm not changing the answer. If I was to times 1 by 5, I get 5, 2 by 5, I get 10, and 3 by 5, and I get 15. And I'm still keeping true to the equation. That's what we do here when we don't have two exact terms. So I look at equation 1 and I look at equation 2 and say the easiest thing for me to do is probably going to be to take this equation 1 times it by 3, because what will end up happening with this middle term is I end up with 3q. Let's look at that. We have to write out what we're doing. We're going to take equation 1 and we're going to times it by 3. That gives us, so 3w times by 3, that's 9w. Q times 3, that's 3q. And 6 times 3, and that's 18. We haven't changed the function of the equation. We've just changed the numbers, but it still means the same thing. Now, we call this equation 3, and if we look at equations 2 and 3, so I don't need equation 1 for this point. I'm not going to use it again. But if I look at equations 2 and 3, I notice that I have 3q and I have 3q. One's negative and one's positive. When we went back to the textbook, when there was one negative and one positive, like question 1a, we added the equations. So we're going to add equation 2 and our new equation that we made. We're going to add those together. 2 plus 3. What happens when we add 2 and 3? So 2w plus 9w gives us 11w. Negative 3q plus 3q, they get cancelled out. And 15 plus 18, that's going to give us 33. We can look at that and say, well, that means w is going to equal 33 divided by 11, which is 3. We have half of our solution. Remember, when we're solving simultaneous equations, there's two solutions. There's a solution for each of the two letters. I'm going to come back to equation 1 because that's going to be the easiest equation to find out what q is, because it already has q by itself. All we need to do is substitute w for 3 and we'll be able to get the answer for q. So we're going to sub w, which is 3, into equation 1. And equation 1 was 3w plus q equals 6. So 3w, which is w is 3, plus q equals 6. 3 times 3 is 9, plus q equals 6. To get rid of 9, we're going to subtract 9, so q equals negative 3. Our solution is w equals 3, q equals negative 3. I'll do question C, and it's going to be the same the same process. We look at our variables and we don't have anything that's the same. So we have 2D, we have D, 3H, we have 4H. None of those are the same. So what we have to do is we have to make a third equation. We have our first two equations here. We look at that equation 2 and we can turn D into 2D. We can't turn 4H into 3H or vice versa. But if I times everything here by 2, I end up with 2D. So I'm going to take equation 2 and I'm going to times it by 2. That will give us equation 3. So equation 2 times by 2. So D times by 2, 2D. 4H times by 2, 8H. Negative 5 times by 2, negative 10. That's our new equation. We have, in equation 1, we have 2D. In equation 3, we have 2D. We'll forget about equation 2 for a minute. And we have equations 1 and 3. What we need to do now is we need to subtract them. This is, in a previous video, I spoke about picking, when you're subtracting, picking which one to subtract, which one to start with. If I subtract 1 minus 3, 2D minus 2D, that's going to go away. But 3H minus 8H, that's going to give us a negative answer. So I'm going to do it in reverse. I'm going to take equation 3 as my starting equation, and I'm going to subtract equation 1. So I'm going to start from the bottom and I'm going to subtract the top. 2D minus 2D, they're going to cancel. 8H minus 3H, that gives us positive 5H. And negative 10 subtracting 25, that's going to give us a negative 35. When we divide by 5 on each side, we get H equals negative 7. That's our first solution. Now we'll come back and use equation 2 because that will work. It has D by itself, so that's going to be the simplest equation to solve. So we're going to sub H equals negative 7 into equation 2. So anytime I see H, I'm going to put negative 7. D plus 4 times negative 7 equals negative 5. D minus 28 equals negative 5. To get D by itself, I'm going to plus 28 on both sides. So that's going to get rid of this 28. D equals negative 5 plus 28, that's 23. And that's our solution. H equals negative 7, D equals 23.